do you determine the scale factor of a dilation given the side lengths of the pre-image and image? In this lesson, you will learn how to calculate the scale factor of a dilation comparing measurements of an image and pre-image. Let's review. A dilation takes a pre-image to an image using a scale factor and a center of dilation. In this diagram, NM is the pre-image, the center of dilation is at 0, 0, and the scale factor is 2. N prime, M prime is the image after dilation. It is parallel to NM and is 2 times as large as NM. You should also recall that if the center of dilation is at 0, 0, you can calculate the scale factor of dilation by dividing the corresponding vertices of the image and pre-image. Let's look at the x values. We have N prime and N. And if we look at their x values, you can find the scale factor would be the x value of n prime, which is 4, divided by the x value of n, which is 2. And that simplifies to 2. Therefore, the scale factor is 2. Another way to calculate the scale factor of a dilation is to find the ratio of the corresponding sides of the image and pre-image. We will call this ratio K. So the scale factor K of A, B, C, D to A prime, B prime, C prime, D prime is equal to the image length divided by the pre-image length. The scale factor of K is equal to the length of A prime, B prime divided by AB, equaling B prime, C prime divided by BC, equaling C prime, D prime divided by CD, equaling D prime, A prime divided by DA. And if we look at the side lengths of each of these, we will see that K is equal to 8 divided by 4, equals 4 divided by 2, equals 4 divided by 2, equals 4 divided by 2, and they all simplify to 2, therefore our scale factor is 2. In a dilation, the ratios of the pairs of the corresponding sides must all be proportional. A common misunderstanding is assuming that given an image, one pair of corresponding sides is the K value. And that's not always true. You must check all sets of corresponding sides. So let's look at this diagram here. If we were to find K, we would take 1.5 D prime C prime divided by 1 DC, 3 divided by 1.5, 3 divided by 1.5, and 5 divided by 3. Those are the ratios of each of the corresponding sets of sides. When you simplify them, you get K equaling 1.5, 2, 2, and 1.6. Since they are not equal to each other, this is not a dilation, and there is no scale factor. A dilation with a scale factor of K greater than 1 is called an enlargement. In this diagram, we have the pre-image, PQR, and its image, P prime, Q prime, R prime. The scale factor of the pre-image to the image is equal to the ratio of P prime R prime divided by PR, equaling P prime Q prime divided by PQ, equaling Q prime R prime divided by QR. When we look at the side lengths, we will have K equaling 3 divided by 2, equaling 3 divided by 2, equaling 3 divided by 2. And they all simplify to 1.5, therefore the scale factor is 1.5. And P prime Q prime R prime is an enlargement that is 1.5 times as large as PQR. A dilation with a scale factor of K between 0 and 1 is called a reduction. In this diagram, we have the pre-image LMNO and its dilated image L prime, M prime, N prime, O prime. We're given the lengths of the sides. We can find the ratio, or the K value. K is going to equal L prime, O prime divided by LO, equal O prime, N prime divided by ON, equals N prime, M prime divided by NM, equals M prime L prime divided by ML. When we look at the side lengths, we'll see that the ratios are equal to 3 over 6, 2 divided by 4, 3 divided by 6, and 2 divided by 4, and they all simplify to 1/2. Therefore, L prime, N prime, M prime, O prime is a reduction with a scale factor of 1/2, and is 1/2 the size of L, M, N, O. A dilation with a scale factor of 1, the image and the pre-image are the same size and shape. That means that they're congruent. So here we see that A prime, B prime, C' are on the same spots as A, B, and C. When we look at the ratios, we see that K is equal to A' B' divided by AB, A' C' divided by AC, and B' C' divided by BC. When we look at their side lengths, we see that K is equal to 3 over 3, 5 divided by 5, and 4 divided by 4, which all simplify to 1. Therefore, A', B', C', and ABC have a scale factor of 1 and are congruent. We have looked at 3 specific types of dilation: an enlargement where K is greater than 1, a reduction where K is between 0 and 1, and congruent triangles, or figures, where K is equal to 1. In each of these cases, the scale factor of K of the pre-image to the image is equal to the image length divided by the pre-image length. In this lesson, you've learned how to calculate the scale factor of a dilation by comparing measurements of an image and a pre-image.